Here is the January 2009 Regents Math B exam. We're going to start from question 1, hopefully go through the entire exam just like we did for the Regents Math A exam earlier. So question number 1, the parabola shown in the accompanying diagram undergoes a reflection in the y-axis. Okay, so reflection means we're going to treat the y-axis as if it were a mirror. Right, so that's what's going on. We're going to reflect this parabola here about the y-axis. Okay, and it asks, what will the coordinates of the turning point be after the reflection? Okay, turning point, usually this is referred to as the vertex, but it's that point right there, and that is coordinates 1, 2, 3, -1. So that's 3, -1. And what we want to do is reflect this about the y-axis, so we're going to bring it over here, but it's not just going to be on the x-axis, it's going to be 1 down. So the new coordinate is going to be -3, -1, because we have reflected it about the y-axis. So -3, -1 is the answer. Problem number 2 says the expression 5 over quantity 3 plus square root 2 is equivalent to one of these expressions. Okay, and here we have to do something called rationalizing the denominator. And the way to do that is to multiply this expression by 3 minus the square root of 2. You take the opposite sign of whatever's in front of the square root, and that will get rid of the square root in the denominator. So let's take 5 over 3 plus square root 2, and do as I said before, we're going to multiply by 3 minus square root 2 over 3 minus square root 2. If you're wondering, why do we always multiply, by the same thing over the same thing? It's because in algebra, when you multiply by 1, you don't change anything, mathematically speaking. You change the way it looks, but you don't change, what it ultimately means. So this is just another expression for 1. So let's carry through with this and see what happens. We have 5 times 3, that's 15. And then we have 5 times square root 2, which is just going to be 5 times square root 2. We'll leave it like that for the time being. And then in the denominator, we're going to treat this as if it were, product of binomials. That's exactly what it is. And then we just do FOIL. So 3 times 3 is 9. Then we have 3 times the negative square root of 2, so that's -3 square root 2. Then we go over here, and we have square root 2 times 3, which is positive 3 times square root 2. And then we have the square root of 2 times the square root of 2, but one of these is negative, so it becomes minus. And when you multiply square root of 2 times square root of 2, you get positive 2, so -2. Again, the minus sign is because the plus and the minus here result in a minus sign, and the square root of 2 times the square root of 2 equals 2. Okay, we can simplify this a little bit. This and this cancel out, and we have 15 minus 5 times square root 2 all over 9 minus 2, which is 7. Okay, and if you look closely at the top, you will see exactly that answer. All right, question number 3. It says, if the probability that the Islanders will beat the Rangers in a game is 2 to 5, which expression represents the probability that the Islanders will win exactly 4 out of 7 games in a series against the Rangers? So we want them to win exactly 4 out of 7 games in a series against the Ranger. All right, so let's break this apart here. We have the probability that they win, right? The probability that the Islanders will beat the Rangers, so win, is 2 over 5. That means that the probability that they lose has to be 3 over 5. Okay, and this should make sense because either you win the game or you lose the game. And these kind of math questions here, if there's a third option, they'll tell you. But usually it's pretty black and white in these problems. It's win or lose. And the sum of these probabilities is 1, which means there's a 100% chance they will win or they will lose. So if the probability of winning is 2 over 5, probability of losing is 3 over 5. And that's because 2 plus 3 equals 5. So we want these guys to win 4 out of the 7 games, right? Well, if they're going to win 4 of them, that means there's 2 over 5 to the 4th power, because they can win them 4 different ways. And then it's a 7-game series, so that means the rest of them they're going to lose, and this is going to be to the 3rd power. So these represent the 4 games that they win. This represents the 3 games that they lose. Okay, but we're not quite done, because what we have here is a series of W's and L's, essentially, and the order doesn't really matter. We only care that they win exactly 4 of them. You know, this keyword here, win exactly 4 of them. So we need to show that there's a combination happening here. They have to win, out of 7 games, they have to win 4 of them. So this is just the symbol that says how many different ways can you combine 4 objects out of 7. 4 wins out of 7 games. So this is wins, this is games. Okay, 7 games, 4 wins, and this just means combine. Okay, combine. The order doesn't matter. Okay, we'll see you in the next problem.